All right, guys, I'm going to go over some of the questions that you had expressed that you were having a little trouble with distinguishing the difference between. So we're going to start with the difference between matched pairs and two sample t-tests. So we'll do a little side-by-side comparison. So I'll put matched pairs over here. Okay, in a matched pairs t-test, you're going to be given two lists. Um, Usually it'll be in a table form. You'll probably have a A list and a B list, let's say. So what I would say to do is type in your calculator list A, list B, and then what you're going to be most interested in is the difference between those two lists. So in the row where there's an equal sign, you would type in A minus B, likely, and then you would title it something like differences, and that would be the list that you care about for the whole rest of the problem. So you would be using the X bar that you get from only that third column, and you would need the standard deviation as well. When you write your null hypothesis, you only have one mean that you're dealing with, that you're trying to find, and it's the mean of the differences between A and B. The null would be that the difference is zero. In other words, that there's no difference. The alternative would be that the mean of A minus B would either be greater than or less than or not equal to zero, just depending on the wording of the problem. The bottom line is that there's only one mean. Sorry, my husband is printing something out, so you're going to hear the printer run. There's only one mean in this problem, and it's the mean of the differences. So when you're writing it out, you would be interested in the true mean difference. So it's singular. There's only one. All right, let's compare that with a two sample. Okay, two samples gonna go over here. You might be given a table again, and in that table you might have A and B. But the difference now is that these are two completely separate groups. So we would be dealing with a mean from each of the lists. So when you're thinking about your hypotheses, the null hypothesis, you could write a couple different ways. One way to say it would be that the difference between those two means is zero, meaning, again, no difference. The alternative would be that the difference between those two means is maybe greater than zero or less than zero or not equal to zero. That would be one way you could write them. Another way that you could indicate the same information, you could say that the null is mu1 equals mu2. The alternative would be that mu1 is maybe less than mu2 or greater than mu2 or not equal to mu2. But the main idea is that there are two means So that's plural. And when you're writing your description of what you're trying to find or what you're interested in, and you're interested in the true difference in the means. Oop, we gotta move that out of the way. Okay, so with matched pairs, you're interested in the third list of the differences. Your hypotheses only involve one mu. Your writing is talking about a singular, only one mean. If it's two sample, you're going to have two separate lists. You're going to have two separate means. When you write your hypotheses, you're going to have two mu's. Two means is plural. Make sure that your writing is indicating that you've got the difference in two different means. That's the general structure. Now I want to talk a little bit more about how can you tell the difference based on the wording of a problem. So let's start with matched pairs again. So with matched pairs, you will either be told that things are being paired up, or you will have some sort of sense that each subject is receiving two treatments. And those two treatments should be decided at random. The order should be decided at random. So we've had an example before where like a worker is listening to music one week and then not listening to music another week. So that doesn't mean that everyone is going to listen to music first and then not listen to music second. That order is going to be decided at random. So maybe like the flip of a coin, heads, you listen to music first, tails, no music first. Also, another thing is that your a dead giveaway would be that your lists would be the same size. That does not mean that anytime you have two lists of the same size, it's automatically matched pairs. That's not true, but the opposite is true. So they have to be the same size in order for you to have them paired up. Okay, let's look at a two sample. Two sample would be you've got two completely independent groups. So like we had an example where it was like suburban versus urban, or it could be like BSM versus Apple Valley High School. Two completely different groups. Sometimes they will be the same size. But if you notice that they are different sizes, it can't be matched pairs. So if they're different sizes, that is a clue that it's not matched pairs. Let's see. The reason why these get confused so easily is because both of them are dealing with means. And if we go back to the previous page, likely you're going to see a table in possibly both of the problems. Occasionally, you might see where they just give you X bar 1, SX1 and N1, and then maybe they give you X bar 2, SX2, and N2. So they might give you those stats, but they might also give you the data. And it's when they give you the data, that's when people confuse it for matched pairs. Okay, the next thing I want to go through are all of your choices so far. So I think I'm going to type these out because this might be faster. So we could have one sample t interval, or it could be a t-test. We could have a 2-sample t-interval or t-test. We could have a 1 proportion z-interval or z-test, 2 proportion z-interval or z-test, or we could have a matched pairs t-test. So those are all the ones we've learned so far. And actually, because of the way that they're restructuring the AP test, those are the only ones we need to cover. So lucky for us, we got through everything we needed to before online school happened. So that shows us that we were on a really good pace. Again, the two that get confused the most are a 2-sample and a matched pairs. Those are the ones that get confused. So if I had to guess, I would say one of those would probably be on the AP test. Let's see. T always goes with sample. Z always goes with proportion. Let's see. What else did I want to say about that? I can't remember. Okay, let's talk about how do you know if it's an interval versus a test. Here, let me talk about this real quick. This is what I wanted to say. I just forgot. With these 1-sample or 2-sample, those are problem involving means. And you can only have problems involving means if you have quantitative data. So you got to have numbers. If you're doing problems that are involving proportions, then you're going to have categorical data. Categorical data would be like maybe opinions. Or something that puts you into a category. All right, so then let's talk about the difference between panic and phantoms. Panic is what you do when you are doing a confidence interval. There's an I and a C in panic. C for confidence, I for interval. So that might help you remember confidence interval. Do this if you're told to estimate something. Do this if they give you a % confidence in the problem, if it says anything about a % confidence. Do this if it says anything about an interval. Those are the key words to look for. Phantoms is when you are doing a significance test. And in the word phantoms, there's an S for significance and a T for test. Significance test. Do this if they are asking you if there is evidence for anything. Do this if they use the word test. Do this if it says in the problems anything about statistically significant. So like if it asks you if there is statistically significant evidence, remember, in order for something to be statistically significant, the p-value has to be smaller than the alpha. That means that you reject the null and you do have evidence. So that's kind of like the key words that I look for in any given problem. I look to see what kind of data do I have? Is it quantitative or categorical? That's going to help me decide if it's means or proportions. Then I think, okay, am I dealing with one mean or two means, one proportion or two proportions? T always goes with means, Z always goes with proportions. And then I have to decide, is it an interval or a test? So that's where I come down and I look at keywords like this. Are they asking me to estimate or are they asking for evidence? Do I see a percent confidence or do I see something about testing for statistically significant evidence? So those are kind of the key words to think about. Another question that students have asked is the whole idea of robust. And robust is dealing with the normality condition. So here's how it works. If you are doing a Z interval or test, it has to be perfectly normal. In order for you to be able to use your Z chart, you have to have a totally normal curve. T, though, is not exactly normal. It's close, but not quite. So even if the population is not normal, even if the population is not normal, you can still maybe use T. So what you want to check, if the population is not normal, you would want to check the central limit theorem. See if that works. Is your sample size greater than 30? If that doesn't work, then you can try a normal probability plot. And you're wanting to know if that's linear. If that works, or if central limit theorem works, then you can still use T procedures. So that's what robust means. Even if your population is not normal, there's a little bit of wiggle room because T is robust. It stands up to a lot of crap, I guess you could say. And then here's the last idea. I've already said this, when you have proportion problems, those are going to be Z. And if you have mean problems, those are going to be T. There's an exception, and it does not happen very often. The exception would be if you know the population standard deviation, so if you know sigma, then you can use Z even if it's a mean problem. But this exception does not happen very often. So I would say in general, T goes with means, Z goes with proportions. Okay, I think that covers most of your questions. But again, feel free to visit office hours anytime. All right, have a good day.